Hi, welcome to my submission of the AMD Open Hardware competition in 2025. My name's Finlay and I'm over at the University of Strathclyde in Glasgow, and this is an introduction to my project, which is called System-on-Chip Based Emulation of Quantum Circuits. Access to quantum hardware is very limited. This project proposes an emulator that allows users to run quantum gates and a quantum Fourier transform on a multiprocessor system on chip. The project itself was designed using Model Composer, Vivado, and PYNQ. So each gate and the quantum Fourier transform were broken down into basic mathematical operations happening on the qubits, and these were represented in blocks in Model Composer, which was then transformed into a bit stream in Vivado, and there's an interactive element on the PS side where users can sort of interact with a GUI created in Voila, where they can visualize the transformations happening to qubits. So here you can see the GUI, and we're on to the first bit, which is visualizing qubits. So it's a little explanation on qubits themselves, what they are, and then you can scroll down and see the block sphere where a qubit can be randomly generated. You can move the block sphere around. The next bit is the quantum gates. There's a little drop down box and you can choose what quantum gate to emulate. So here's the X gate. You can see the block sphere here before and after, and onto the Hadamard gate here. So behind the scenes, this will call a bit stream that runs the associated bit stream basically for the gate that you've chosen. You can see the qubit before and after. Onto the quantum Fourier transform here, you can scroll through the sort of different input states from 0, 0, 0 to 1, 1, 1, and there's 3 qubits in and 3 qubits out, and you can see the block spheres for each qubit here. Thank you so much for listening.